Hello, my name is Wai Han. I'm a tutor at the Department of Architecture, National University of Singapore. For today's talk about resilience in the city, I'd like to talk about it through a studio project that I embarked on last year for the Seoul Biennale. It is called The 80s Mosquito, the City and Citizenry. I chose the 80s mosquito because it is the carrier of the dengue virus. There are two mosquitoes, the Aedes aegypti and the Aedes albopictus mosquito that carry this virus, the former being the more effective of the two as a disease vector, but the latter, as we shall find out later, is pretty important too because it is resistant to cooler climates. Also, both of these mosquitoes are urban mosquitoes. Today's presentation is divided into 6 parts. How the Aedes mosquito has followed us into our cities and bringing dengue to many places. How we have many effective weapons against the Aedes mosquito, but the most important one that I think, or we think that architecture can solve is how to create a collective vigilance. And we will discuss this through 4 discursive projects done by my students. And hopefully these would spark some debate about resilience, safety, and risk in the city. So the Aedes mosquito has followed us into our cities. Aedes aegypti evolved in West Africa as a canopy species feeding on monkeys. When humans felled trees, mosquitoes came down to the ground level and found a new host, which was us. Aedes aegypti flew out of the woods into our gardens, out of the ahistorical wild, a place expected never to change, and into the city, a place expected never to evolve. The urban Aedes aegypti has evolved into a separate subspecies. This is a map of Singapore. These are all the hotspots for dengue fever. This graph shows the number of dengue cases from 2017 to 2021. As you can see in the blue, 2020 was a particularly bad year for dengue in Singapore. There were more dengue deaths than COVID deaths. There were 30,000 cases of dengue, of which unfortunately I was one. So this is where dengue, though killing fewer people than malaria globally, is growing at a far more alarming rate. This is primarily due to growing shifts in global populations to cities and the increasing rate of travel and trade between countries. You can see from this graphic here, from the mid-20th century till now, dengue has been spreading in subtropical areas, but it's also interesting or alarming to notice that because of global warming, this will increase the geolocation of Aedes mosquitoes to higher latitudes, spreading disease amongst new populations, especially those in cities in Southern Europe and parts of North Asia. So it was only in the late 19th century that it was discovered that mosquitoes were responsible for carrying diseases such as malaria and dengue. Before that, it was thought that malaria and dengue were airborne diseases. So we have invented all manner of ways to prevent them from biting, to prevent them from breeding, and effectively prevent them from spreading. But there's one weapon that I think that architecture could have a role in encouraging, and that's a collective vigilance. So these are some of the tools that we use: chemicals, mosquito nets, fumigation, mosquito coils, citronella. But however, one of the pesky and things about mosquitoes is that they can breed in very, very small pools of stagnant water. And we can find this all over the city, from very, very small indentations in the ground or in flower pots or rubber tires. So it is often, I mean, these are often due to our carelessness, and therefore, this collective vigilance, we can sense it in our propaganda. You know, how to encourage people to check for breeding places in their homes, make sure that they empty out any kind of plastic receptacles, don't collect rainwater, make sure that your roof gutters are clear. It is very, very, very small things when done collectively at the scale of thousands of, if the whole city did all this, then we wouldn't have more. So in the next 4 projects, you find 4 discursive projects. I wouldn't say they are, I would say they're more speculative projects that look at the ways of eradication and prevention, but mix them in with architecture and try to create objects that encourage a collective action or make collective action very visible. So we have 4 projects: a human bait mosquito trap, the no stagnant water pavilion, a fumigation folly, and a citronella loop. So the human bait mosquito trap, I mean, I encourage my students to have very, very explicit names for their projects. It's literally using the idea of how the mosquitoes look for us. So the most potent chemical that the Aedes mosquito can sense is the carbon dioxide from our breath. So that's the first thing that triggers them to fly in a particular direction towards us. The next thing, they would smell our body odor, they would see our body heat, and then they would taste on our skin where they can find a blood vessel to sink their proboscis into. So this project also looked at a device called a gravitrap. So gravitrap is used by researchers and used by health agencies. It is placed all over the neighborhood to check about population densities of mosquitoes, and it uses a very particular habit of the mosquito, which is only the Aedes mosquito, which is to lay their eggs slightly above water in the expectation that the container will fill up further water. So based on this, the students concluded that the best attractant for mosquitoes is carbon dioxide. The best bait to use in a trap would be a human being. And when do we expel the most carbon dioxide? It's when we do exercise. So the most attractive bait for a mosquito would be an exercising human. And so from these very cute GIFs you can see here, the students are looking at different types of exercise equipment that they can use, and the power of human action to expel carbon dioxide, but also to suck in mosquitoes and kill them. So well, we're jumping ahead quite a lot, but in their final project, they envisaged a kind of fitness corner with 3 rowing machines. So there are 3 humans there because we need that volume of carbon dioxide to attract mosquitoes. So as you can see, they're sitting on the rowing machine. They have a mouthpiece attached that is connected to a trumpet above, and the trumpet is expelling carbon dioxide and attracting these mosquitoes near to this fitness corner. Mosquitoes are very bad at flying. They never fly more than 500 meters away from where they were born. So as you can see, as they approach this machine, there are trumpets at a lower level, and these would suck up the mosquitoes and kill them. So here's another view. Perhaps the last view a mosquito would see near this device, but it makes mosquito killing communal, very visible, and very participatory and fun. Kind of like the fun you have when you use those electrocuting, mosquito killing, zapping rackets. Here's another view inside. And so the second project we have is the No Stagnant Water Pavilion. So this group of students were looking at stagnant water and how it occurs in our drains, in our gardens, any kind of household receptacles and pots. And they were looking for a long time, how can architecture solve this? How can architecture solve this? Seemingly non-architectural, like it looks like it shouldn't have an architectural solution. And then I think through sheer frustration, you just thought, hey, let's make a water collection structure that is inherently unstable. It would never ever have stagnant water. So this conceptual diagram, and over here you can see a scaled 3D model of a pavilion for water collection. So water collection is a bit of a problem here. People like to collect, and if you take care, then mosquitoes will start to lay their eggs in the water. So here it is like a pub water pavilion. It is made of a kind of sort of rounded base, and depending on how the water fills up in the pavilion and the way you use the pavilion inside, the center of gravity will cause this pavilion to tip and to rock gently, constantly. So the mosquito will never have any chance to lay their eggs. But even if they lay their eggs, the water would just like splosh out or something. So in this way, this is envisaged to be a kind of communal space where people collect rainwater, but at the same time, it never ever collects stagnant water, and you'll never have mosquitoes breeding. The fumigation folly was looking at smoke and fumigation, which is often used at a very private level. Like we would use a mosquito coil, put it in the garden or under the bed, and it would deter mosquitoes from coming, but it would just mean mosquitoes would fly off to your neighbor's house. I mean, just like fumigation, when certain estates fumigate, it'll kill some insects, but some of those will just fly off. So in this project, they were looking at the way smoke behaves and how it spreads, and they envisaged a type of a pavilion, like a pyre, which you would light, and it would smolder and create smoke that in a park. Let's say this is in a park, it would have smoke that repels mosquitoes, kills mosquitoes. In this pavilion, some parts of it are flammable and some parts of it are not flammable. So the students designed it to create like a space inside the pavilion, and you could even sit down inside and have a smoke spa if you wanted to. Finally, we're going to look at citronella. So citronella is something that is extracted from a lemongrass plant, and it is a well-known natural chemical repellent for mosquitoes. So the student was looking at playgrounds and how, if you go to a playground in Singapore, it smells completely of citronella because parents are smothering their children with citronella so they won't get bitten by mosquitoes. And he decided to use the idea of the action of weaving to create a kind of a public playground that's actually a loom. The loom is infused with citronella oil, and when you get onto this pavilion, you would weave, and your hand would get slowly infused with citronella oil, and so in this way, just like during COVID times, you have hand sanitizers everywhere. This is like a public citronella diffuser, but it is also fun to use. So these are the 4 projects. that were developed last year. They're all very small and very highly speculative projects that I would say are kind of closely linked to the Biennale's theme of safety and risk and how architecture can adapt to unexpected risk. It was interesting to look at these small projects and look at how they affect the world around them, or even imagine what type of society would be around them that such objects could exist. So, you know, global warming is making dengue a risk for cities, and dengue is seemingly such a big problem for even cities that are very well managed and rich, like Singapore. Like, we throw so much labor into checking for mosquitoes, but still, it is a big problem. And you know, just like how the public health warning posters suggest, you know, it is maybe not. It takes the whole population. It takes the whole of society. It takes the citizens to take responsibility and collectively participate collectively to deal with mosquitoes and take these actions outside the privacy of your home into the public, and make this like a public effort. So just like how during the lockdown, a lot of us started to depend on friends and family or even our neighbors to get through the lockdown through the collective power of small acts. I think maybe, you know, this studio was inspired because it was conducted during the lockdown. And so, you know, how can architecture promote this type of public participation, and possibly architecture and city planning, like how can it inspire a collective vigilance of citizens, you know, against this this age-old pest. So thank you for thank you. That's hope you found this interesting. This is the end of my presentation.